All right. I want somebody to go into the depth of what I'm going to write here. And then, if possible, bring a presentation. That's why I put a PowerPoint logo. There is something called as a speed. There is something called as a waste. So that's why I put this guy with a car and a dustbin. Speed and waste. Little's law. We are talking about speed and waste. And remember these two probably new terminologies. How many of you don't know Little's law? Type NO in the comment box. I just wanted to know. It's okay if you don't know, because even many of us don't know many things. Okay, you can type no issues. Okay, I'm generally checking because this is a mixed type of audience. So in order to go into the depth of certain things, I would ask these questions. And since people who have enrolled here can come to any number of sessions, for those, you might have seen this probably for second time or third time. Okay, great. So you have to remember what is called as Little's law, and you have to remember what is called as PCE, which is process cycle efficiency. Easy things first. Process cycle efficiency is very easy. We have already indicated that in a different way earlier. It is nothing but take the value added time. What is its percentage with respect to the total time? And we know total time consists of value adding, value enabling, and non-value adding. So with respect to total time that you take from order to delivery, for example, what is your percentage of value added time? And that's called as a process cycle efficiency. Little's law says, okay, the lead time is nothing but the total inventory by average customer demand. Okay, suppose if you have, or you can even calculate total inventory. If you say your lead time is so much and the average customer demand is so much, you can even calculate inventory. What I can tell you, suppose if you give me a data which says that your order time, your order to dispatch time is so many days, for example. If you give me 50 orders and I calculate, of course, odd man out, I'll take it out, and I have my own way of statistical analysis to see the sanctity of the data. But with that data, I will arrive at what is the lead time that you're taking. And I would ask you, okay, for this order, for this product, what is the average customer order? And with that, the lead time multiplied by average customer order would be the average inventory that will be total average inventory that would be staying inside your plant. So mentally, I can approximately calculate. The more is the lead time, the more would be the inventory. That's what it means. Okay. All right. Efficiency, we have already seen here. So what I would like to show is, due credit to Professor Gundlekar, Dr. G, as he fondly called, from Wellinger Institute in Mumbai. So this is taken from his video. It is actually his video that I want to give credits to him and show how he has demonstrated in his college while he was teaching this Little's law, which is very interesting. If you're ready, type BIO, bring it out in the comment box.
We always start with the customer. So let's invite the customer, okay, which may be our sales department or something. So glad to meet you, sir.
Same here, sir.
Yeah. So what do you want for the next month?
According to the current market conditions, we want 32 cars per day.
32 cars per day.
Yes, sir.
Alright, of the same variety or different varieties?
Different varieties, sir.
Different varieties. Alright, you will get it. Thank you very much.
Thank you, sir.
Yes. Now we have to set up 32 cars per day. I work in an 8-hour shift, which means 4 cars per hour. So our production rate is going to be 4 cars per hour. 4 cars per hour. Right. Now, let us see how to set that.
So this is our conveyor belt. The car would be assembled in various steps on this conveyor belt.
Now, one question here is, at what rate do we want to make the assembly?
4 cars per hour.
That means what?
That means after 15 minutes, one car has to come out.
And?
And after 15 minutes, one car has to come inside.
Absolutely. So this 15 minutes is now called as the takt time. Right? Takt time. The takt time becomes 15 minutes. Alright. Now, the next question we need to ask is, what is the throughput time? That means, what is the time from which one car, when it enters the conveyor belt, how much time does it take to exit from the conveyor belt as a complete vehicle? And this time is, we are told, 2 hours. Okay? Let us see what happens if we have a completely empty factory like this and we start assembling the vehicles. Alright? The first vehicle comes in. The first vehicle comes into the first station. How long will it work?
15 minutes.
Right. And after 15 minutes it will move ahead. Okay. Then comes the next vehicle. Yep. How long will it be here?
15 minutes.
Yeah. And what about the previous car?
Oh, that will also be for 15 minutes.
Right. So let's say 15 minutes are up.
This moves ahead, this moves ahead, and the new car enters.
Right. Another 15 minutes are up.
This moves ahead, this goes ahead again, this also goes ahead, and we have another car coming inside.
15 more minutes happen.
It moves to the next station.
Right. In these 15 minutes, every station has got to complete the job assigned to them. Alright? 15 more minutes happen.
It moves ahead.
Right? 15 more minutes happen.
It moves to the next station.
It is getting assembled. Every car is getting assembled at that station. Yeah. Another 15 minutes happen.
It goes to the final station.
Alright. So the yellow car that we started with, if you can point out to it, has now reached the end. It is waiting for its last 15 minutes. The moment those 15 minutes are over, the car goes out. So let's say those 15 minutes are up.
The car goes out of the production line.
And as a result, each of the cars
Moves ahead.
move ahead. Yeah, by one. Right. Now, how long did it take for the yellow car to move from the first station to the last?
2 hours.
Why 2 hours?
Because that was the throughput time.
Right, perfect. So given the throughput time of 2 hours and a takt time of
15 minutes.
15 minutes, how many cars are there in the system? Would you please count?
1, 2, 3, 4, 5, 6, 7 and 8.
So 8 cars are there in the system, right? If production continues, what will happen? Let's say one more car, 15 minutes gets over. So another car goes out of the system and all the cars move ahead.
By one operation.
The result is, how many cars are there in the system now?
8 cars.
Still 8 cars. So always 8 cars. Now how did we get the 8 cars? Can we see any kind of relationship? We have said that the throughput time is 2 hours. So can you see any relationship? We can see that the WIP, which is the 8 cars, is actually 2 hours, alright, multiplied by 4 cars per hour, which gave
8 cars.
8 cars. 4 cars per hour, which is 8 cars. Now, ladies, for you a new challenge. The challenge is, can you reduce the throughput time from 2 hours to 1.5 hours?
Oh yes, we can try. By a close observation at every station and clearly identifying the non-value adding services. Yeah, we can remove the non-value adding activities, thereby reducing the throughput time. Do you mean Muda? Yes, I mean Muda.
Okay, so suppose they are successful and the throughput time comes down from 2 hours, it comes down to 1.5 hours. Let us see what impact will it have. What will it do? It will reduce the
WIP
to
6 cars.
6 cars. Can you demonstrate to us how the conveyor will start looking like? Alright, we have shortened the conveyor in a sense. Okay, WIP down. What is the impact on cost?
Reduces.
Alright, which cost?
Working capital reduces.
Right, and your throughput time is down, so you are now in a position to produce faster in case you once again put the 2 back.
All right. So if you like the video, just give credits to Dr. G. Give a thumbs up to Dr. G. Okay. And full credits to him for this. All right. Okay. Other lean metrics. What are the other lean metrics that we can talk about? Let's see. So metrics to determine whether a process is lean. Let's see what are the metrics. Of course, we said speed and waste, which is process cycle efficiency. But remember, there are various metrics in your organization which is actually related to speed and waste. Inefficiencies coming at different domain forms ultimately end up in this. Okay, and what are they? Rework is one such thing. I want everybody to type whatever that they can get in the mind. I'll show some process time. I request everyone to type whatever metrics they feel is. Yeah, rework is written there. Setup time, excellent. Just bring it on so that I want some good participation in the session. Setup time, what else? Transfer time, okay. Waiting for material, information, okay. Breakdown, yeah. Cycle time, communication, yeah, yes. Okay, so machine uptime, roll throughput yield, freight premiums, inventory turns, days late response time, changeover time, first pass yield, distance traveled. I'm just giving some indicative metrics, okay? Number of touches in some industries, wait time, number of process steps, conversion or proposal time, samples. This is not an exhaustive list. This is only an indicative list, okay? So the point here is, ultimately, what is not measured cannot be improved. So we should see the sources of instability. What is that is really manifesting itself into an inventory that is leading to increase in the lead time. That is the speed breakers, right? All these are speed breakers. So waste versus speed. Often these leading indicators are used as project metrics and they are related to speed or waste in any process. If this is clear, please type clear. Let me share the same thing. I want to share the concept of what is called tag time. Okay, the tag time is the speed of the customer. Reinforces the concept of making only what is needed, no production, and it's driven by demand. So this is something that you'll have to remember. But people always confuse. I always say T by D. Okay, I say T by D. Like you can remember T and D because both of them are of the same phonetic. But then people get confused whether T will come in the numerator or D will come in the numerator when calculation of takt time. It will be interesting for you to note. So all the other times are actually measured, can be measured using a stopwatch. Takt time is something that cannot be measured using a stopwatch. This is my observation. Okay, because takt time is actually derived from the total time that is available to you by the demand of the customer. So since it is time in seconds, the small t, which is time, always comes in the numerator. That much you should remember. Okay, if there is a confusion. So what is the time available? Time available, productive time available for making the parts. In fact, when we go to the depth of the value stream mapping, we'll be talking about what is the ultimate time that is available to all of us. 24/7, right? 24/7 is the total time available for all of us. Similarly, for the machines also, 24/7 is available. But then we decide to operate. Like for example, Saturday, Sunday, you might give off, or holidays you can give off. And there can be a allotted time for operation. In that also, there are planned downtime. I'm trying not to use these words. That's why I'm thinking that is related to TPM. But the time when we plan not to run, for example, tea time, we might decide not to run. Lunchtime, we might decide not to run. For preventive maintenance, cautiously, we might plan not to run, and so on and so forth. Okay. And after removing that, whatever time is available is the time available. Okay. I hope this is clear. And customer demand is, it is easy to say average daily demand. It is easy to say, but it is very challenging to calculate in terms of the type of the product, okay, and the seasonality of the product. When I talk about type of the product, there are primarily two types of products, made to order and made to stock type of products. And there are seasonal products, which is during summer seasons, during winter seasons, or during festive seasons, non-festive seasons, it varies. So to calculate the average daily demand, what is the duration we need to take? Because if you take an year duration, maybe it may not be represented. So that also we will discuss in detail. And takt is actually a German word, T-A-K-T, which indicates the drum beat. This is one example for you, a transactional example. Suppose if 200 invoices per day has to be made and the available working time is 420 minutes. Okay. So the available time divided by the requirement, which is 200 invoices, is nothing but 2.1 minutes. Okay. Even for that, you can calculate takt time.